Hi, and welcome to another exciting episode of Network Concepts Explained in R. In this short video, I will explain a very important network concept, closeness centrality. Now consider the following example of the claimed refugee crisis in Europe. I will use this practical example to explain the closeness centrality concept and how small changes can drastically impact the network. On this map, we see the routes that are currently used by refugees to enter certain countries in Europe. Based on real-life, simplified influx routes of refugees, the following visual representation was made. Closeness centrality can be explained as the mean difference from one vertex to another in a connected network. You can simply calculate it by dividing the total number of vertices minus 1 by the sum of all distances to a specific vertex. As the total number of vertices is the same for each vertex in a network, its closeness centrality is dependent on its position in a network. In this example, the European countries are the vertices and the influx routes of refugees are the connections, or edges as they are called in R. The assumption is made that refugees can travel both ways. It is quite clear that Italy has a central position just by looking at the map. Its longest geodesic is only 3 edges long, or put simply, the furthest country from Italy is only 3 countries away. Because of the central position of Italy, their closeness centrality is probably the highest. Let's have a look in R to find out the closeness centrality. First, load the necessary packages that are able to build and visually represent the network. To demonstrate how the concept of closeness centrality works in the practical example of the European refugee crisis, I will first create a network with vertices, the countries, and edges, the connections between countries. Let me set the width of all the edges to 1. Let's now see how this network looks like. I use the E function to print the edges of the previously made network onto the console, and I use the plot function to visualize all the edges and the nodes, how the countries are connected. Now I can use the closeness function to calculate the network's nodes, their closeness centrality. This will give us insight in how central a node is in a network. The more central a node is, the closer it is to all other nodes. You clearly see that both Italy and Germany have high closeness centrality. Now that we have the closeness centrality measures of the network's nodes, I will now demonstrate how a small change in the network can influence the nodes their closeness centrality. In the refugee example, I will now close the border between Greece and Italy, implying that the connection between Greece and Italy will vanish. Let us first create a new network, but then without the edge between Greece and Italy. Comparing the closeness centrality measure in the two situations show us that in general for every node, country, the closeness centrality decreases. This could imply that countries are less close and connected to another, meaning that it could become more difficult to go from one country to another. Italy is still the country with the highest closeness centrality. Closing the border between Italy and Greece did not decrease closeness centrality for Tunisia and Egypt.